two electrons break homolytically, right? Okay, and the formation of free radicals happen in the homolytic fission. But in heterolytic fission, the electrons in the bond is completely transferred, and we have a formation of carbocation and an anion. As we have discussed in this, we have a formation of carbocation and anion in the heterolytic cleavage. That means both the electrons of a bond, they are transferred to the most electronegative atom, okay, which becomes your anion, and the rest other atom, it becomes your cation. So now we have to compare, as we have to study the reactions, organic chemistry reactions, so we have to compare the stability of the carbocations. So there are three types of carbocations. Primary carbocation, it is also known as 1-degree carbocation. Secondary carbocation, it is also known as 2-degree carbocations. Tertiary carbocations, it is also known as 3-degree carbocation. Okay. Primary carbocation means the carbon which is having a positive charge, it is attached to only one alkyl group. Okay, this R is an alkyl group. Alkyl means methyl, ethyl, propyl, any alkyl group. It may be your CH3, C2H5. Okay. So if it is attached to only one alkyl group, then it is your primary carbocation. But if your carbocation, this is known as carbocation, if it is attached to two alkyl group, then it is known as secondary carbocation. And if your carbocation, it is attached to three alkyl groups, then it is known as tertiary carbocation. So which is the most stable carbocation? 3-degree. So you have to remember 3-degree carbocation is most stable, then 2-degree, and then 1-degree. Why? What is the reason that 3-degree carbocation is more stable? Because we'll see in the next slide here, because these alkyl groups, they exert inductive effect. Inductive effect, or you can say they exert plus I effect. Plus I effect means they donate their electrons, they give their electrons to this carbocation. So what do you think? This carbocation is electron deficient or electron rich? Any carbocation is electron deficient or electron rich? Tell me, what do you think?
Deficient?
Yes, obviously it is having a positive charge, and positive charge is always electron deficient. And if it is carboanion, then it is an electron rich, because you know electron is having a negative charge. So if electron increases, then it becomes your carbanion, okay, which is electron rich. Now this is your electron deficient. So by plus I effect, by inductive effect, all these three alkyl groups, they donate their electron. You can see these arrows. That means they are donating their electrons to the carbocation, okay, to this carbocation which is already electron deficient. So it is favoring this carbocation, right? So that's why 3-degree carbocation is more stable, then second 2-degree carbocation, and then primary carbocation, 1-degree carbocation. Okay. So here it is written that carbon atom with a positive charge has only 3 covalent bonds, not the usual 4, making it the electron deficient. So you know that carbon always form 4 bonds, right? Carbon always form 4 bonds. This is what methane, CH4, methane, neutral. But if I add one carbocation here, then it becomes electron deficient. Electron deficient means now it can form only 3 bonds, okay, not the usual 4 covalent. So any alkyl group attached to the positively charged carbon atom, they are electron donating. We say that the alkyl group have a positive inductive effect, plus I effects. Okay, plus I effect means that they are electron donating and they are helping this carbocation to become stable because it is electron deficient. So they are donating its electron to the electron deficient species. Is it clear why 3-degree carbocation is more stable as compared to 2-degree and 1-degree? No?
Yes.
Okay, write it down.
I'm done.
Okay.
I'm also done.
Okay. Write down explanation. Due to inductive effect, 3-degree carbocation is more stable as compared to 2-degree and then 1-degree. Okay. So what is inductive effect? Alkyl groups push electrons away from themselves and reduce the charge density of the positive charge on the carbocation. So I'm telling you about the 3-degree carbocation. This is my 3-degree carbocation. These are my alkyl groups. So these are in this bond we have electrons. So they are pushing the electrons away from themselves towards the carbocation. So they reduce the charge density of the positive charge on the carbocation, making it more stable. This has the effect of spreading out the charge around the carbocation and it becomes energetically more stable because its positive charge is getting reduced. So this means that the tertiary carbocation with its 3 electron donating, alkyl groups are always electron donating. They are always electron donating. So that's why your tertiary carbocation is energetically more stable from the any 3 types of carbocation.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
I'm done. I'm also done.
Okay. So this is an important point, or you can say the conclusion that the more alkyl groups adjacent to the positively charged carbon atom, the more stable is your carbocation. If you have 2 alkyl groups and if you have 3 alkyl groups, then the carbocation which is attached to the 3 alkyl groups is more stable as compared to 2 alkyl groups.
I'm done. I'm also done.
Okay. So next is your difference between electrophiles and nucleophiles. So carbocations are an example of a species called electrophile. Carbocation is electrophile. They are electron deficient. As you know that carbocation is electron deficient, so they are called as electrophile. Okay, electro means electron and phile means lover. So it is electron lover because it is electron deficient. Similarly, nucleophiles. Nucleo means nucleus, positive charge, and phile means lover. So they are nucleus lovers. So they are electron rich species. They carry a negative charge. Negative charges are always electron rich. Partial negative charge is also your nucleophiles. So you can write down the definition I'm writing here. The definition of electrophile and nucleophile. Electrophiles, as the name suggests, they are electron-loving chemical species. Their attraction for electrons is due to the presence of electron deficient atom in them. Since it is electron deficient, so that's why they love electrons. Okay, and they how to identify electrophiles? They contain a positive charge, or they may be neutral. They may be either positively charged or maybe neutral species. So I'm writing some electrophiles here. So you can easily identify if there is a positive charge, then it is always an electrophile. Cl plus, H plus, NO2 plus, all are electrophiles. But how to identify the neutral ones? So you have to just remember some electrophiles. Free radicals. This is my radical. Free radical is an electrophile. BF3. Remember, we have studied that it is an electron deficient species. AlCl3 electron deficient, that's why it's dimerized to form Al2Cl6. SO3 is also an electron deficient species. And what are nucleophiles? Nucleophiles are nucleus loving chemical species. Always electron rich. They are always electron rich, that's why they love nucleus positively charged. They also can be negatively charged or neutral. So negatively charged you can easily identify, okay, like OH minus, NO2 minus, R minus. Any species which contain a negative charge is called nucleophile. But the neutral species which contain lone pair of electrons, like H2O, NH3. So these are my your examples of nucleophiles. So you can easily identify if there is a negative charge or lone pair, then it is the category of nucleophile. And if there is a positively charged, then it is electrophile. And you have to remember like some examples which we already have covered, BF3, AlCl3, SO3, they are already electron deficient.
I'm done. I'm done.
So these are your homework questions. I hope you can easily solve it. Write an equation to show the homolytic fission of the Cl-Cl bond in a chlorine molecule. You know how to show the homolytic fission, right? By a fish-headed arrows and the formation of free radicals happens. Write an equation to show the heterolytic fission. You can easily show, right? Chlorine is more electronegative, so complete electron transfer of electrons goes here with a single arrow. In chloromethane, including a curly arrow in your answer, which one of the following species act as a nucleophile? Right? Negatively charged. Explain your answer to part C. Which of the following species is act like an electrophile? Okay, so very easy questions are there. So these are your homework questions. Please practice it.
I'm done. I'm also done.
Okay, now let us practice some IPSC names. I'm writing 3 compounds here, 3 species. You have to tell me the IUPAC name of these 3 compounds. Apply all the rules of this nomenclature and then all the names, please let me know. These are very simple ones. The upper one. Okay. What is the name of first compound, Alicia?
2,2-dimethylpropane.
Yes, very good. 2,2 dimethyl propane. Because counting will start from here or start from here when in the same thing. 1, 2, 3. At the second position, you have 2 alkyl groups. So you have to repeat these numbers twice, 2,2. We have to write di, then methyl, then propane. Okay. What is the name of second compound?
3,3-diethylpentane.
Yes, 3,3-diethyl pentane. Because counting will start from here or here when in the same thing, it is symmetric. 1, 2, 3, 4, 5. Since at the 3 position you have 2 ethyl groups, so you have to write 3,3 diethyl and then pentane. Yes, Sharma, tell me what is the name of third compound?
2,5-diethyl. 2,5-dimethylhexane.
2,5 dimethylhexane. But there are more groups. This is alkyl group. This is also methyl group. There's ethyl group. There's methyl group.
2,3-diethyl. Then 2,5-dimethyl.
Then hexane. Right?
Yes.
But I can see only one ethyl group here. Where is the other ethyl group? Yes, Alicia, what do you think? What is the name of this compound?
2,3
253 or 235?
It would be 2,2,3.
223. 5 also then.
Then it's ethyl trimethyl
No. First of all, tell
hexane.
me where does the counting will. Wait, let me just erase. Both of you are telling me the wrong names of this third compound. So first of all, tell me the counting will start from right hand side or left hand side.
Left.
Of course, left, because counting will start from where the branching is nearest. So here we have two branchings and here we have only one branching. So 1, 2, 3, 4, 5, 6. So it is sure that it is hexane. Now you can see here we have 3 substitution only. 2 dimethyl, and at 3 position we have ethyl, and at 5 position we have methyl. So we have 4 substitutions here. Okay, so which one will come first, ethyl or methyl?
Ethyl.
Yes. So ethyl is at the 3rd position. So you have to write 3 ethyl. Then write down all these methyl groups, 2, 2, 5 trimethyl hexane. So the correct answer is 3 ethyl 2, 2, 5 trimethyl hexane. Okay. Okay. Can I erase this slide?
Yes.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Yes.
Write down for this also. CH3, CH2, C, CH3, CH2, CH3. Be careful in this second part. First one is simple, but in second one you have to see the longest carbon chain first.
Done.
Okay, so what is the name of first compound?
I said 4-ethyl 2,4-methyl
Methyl or
hexane.
dimethyl?
Dimethyl.
Yes, very good. 4-ethyl 2,4 dimethyl hexane. Because counting will start from here. 1, 2, 3, 4, 5, 6. So it is 4-ethyl, then 2,4 dimethyl and hexane. What is the name of the second compound?
Three-ethyl 2,3,4 trimethyl hexane.
What do you think, Shama? Is it correct?
I'm not sure.
Why? Just give it a try. What is your answer? First of all, you have to select the longest carbon chain, which is nearest to the branching. So the longest carbon chain which is nearest to the branching is 1, 2, 3, 4. Because if we go from here, then it become only 4 and 5, which is not longest. But here, if we go like this in the continuity, then it becomes longest carbon chain hexane. So it is clear that it is hexane. Now you just have to substitute the things. First of all, ethyl will come as compared to methyl because of alphabetical substituent. So at the 3 position, this is 3 position, you have an ethyl group. So 3 ethyl, then substitute methyl groups. At the second position, we have methyl group. At the third position, we are having a methyl group. And at the fourth position, we are having a methyl group. And this is your longest chain. This is your longest chain. Okay, so you just have to substitute these groups. So at third position, you have ethyl. At 2, 3, and 4, you have methyl. So it is 3-ethyl, 2, 3, 4, trimethyl hexane. Okay, so this answer is correct. If you have any doubt in these, then please let me know.
No.
Well, practice more and more, then I'm sure that you will be confident in writing the UPSC names. So let's wrap up the session here only. In the next class, we'll discuss the types of organic reaction mechanism: addition reaction, substitution reaction, elimination reactions. We'll study all these type of reactions in the next class.